This is LeetCode problem 692, top k frequent words. Given an array of strings words and an integer k, return the k most frequent strings. Return the answer sorted by the frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. We have multiple approaches to solve this problem. For approach 1, we need to know counter function. We first import counter from collections. Counter function can build a hash map or dictionary. Key will be the characters. Value will be how often they appear. In this example, my list is 3 apples, 2 bananas, and 1 orange. Fruit counts equals to counter my list. Print fruit counts. We will get output with a hash map or dictionary. It shows apple appear 3 times, banana appear 2 times, orange appear 1 time. It takes O of n time, where n is number of elements in the list. The space complexity is O of n, where n represents the number of unique elements. This is the coding part. We first import counter from collections as we mentioned in the past. To define top k frequent function, step 1 is to count the frequency of each word and store the records by a hash map. Frequency equals to counter words. Step 2 is to define the sorting order, first by frequencies from high to low, then from lexicographically smaller ones to larger ones when we meet a tie-in frequency, and sort the entire list of all words. Step 3, only return the first keywords as the returned result. Time complexity is O of n log n. Space complexity is O of n. For approach 2, we need to know 2 functions. The first one is heapq.heapify. It is used to transform a regular list into a valid min heap. Time complexity is O of n, space complexity is O of 1. The second function is heap pop. It is used to pop and return element from a heap. Time complexity is O of log n, space complexity is O of 1. Just like approach 1, we need to import counter from collections. We also need to import heapify, heap pop from heapq. Step 1 is the same as approach 1. Step 2, we need to convert frequency hash map to a list. In this list, we will have word and also minus frequency. From there, we use heapify to make the list of the words as a max heap. Heapify convert a list to a min heap by default. In order to get max heap, we have minus frequency here. The last step is to pop the top element from the max heap totally k times. We can use this block of code to achieve this, or this line of the code. They work the same. Time complexity is O of n plus k log n. Space complexity is O of n. For approach 3, we first build a class pair. In init method, we have string and frequency. Then we define a custom comparator less than function. We try to prioritize lexicographical order for strings with equal frequencies. So if self.frequency equals to other frequency, then we return self string less than other string. Otherwise, we prioritize strings with higher frequencies. Return self.frequency greater than other.frequency. In top k frequent function, we first use counter to create a hash map that counts the frequency of each string. Then we create the max heap by performing heapify on all string frequency pairs. Eventually, we pop the most frequent string of the heap k times and return these k most frequent strings. Time complexity is O of n plus k log n. Space complexity is O of n. O of n space is used to store a hash map. At most, O of n space is used for the heap. For approach 4, we can use a min heap instead of max heap. When heap exceeds size k, we can discard lowest frequency words until heap's size is reduced to k again. Now let's look at an example. K equals to 2, and we have a frequency hash map here. For offer 3, we push it to the heap. In this min heap, offer 3 is at the top. Then we push coding 1 to the heap. 1 is the smallest value, so it is at the top of the min heap. Then we push left 2 to the heap. 1 is still the smallest value, so it stays on the top. However, as of now, heap size is equals to 3, k is equals to 2. Heap size is greater than k, so we pop the top value. Then we push day 1 to the heap. 1 is the smallest value, so it stays on the top, but now heap size is still 3. It's greater than k, 2, so we pop the top value. In the end, words remaining in heap are the top k frequent words. To retrieve these words, pop them from heap until it's empty. Because we are using a min heap, we are popping off the less frequent words first, so we need to reverse the order of retrieved words before returning the result. For the coding part, we need to learn a function, which is heap push. It is used to add an element to a heap, maintaining the min heap invariant. Now let's look at the coding part. We first import counter, heap push, heap pop. For a class pair, in init function, we have string and frequency. Then we define a custom comparator as approach 3. Since this is a min heap comparator, we can use the same comparator as the one used in the max heap, but reversing the inequality signs to invert the priority. In top k frequent function, we first use counter to create a hash map that counts the frequency of each string. Then we create empty min heap. For string and frequency, in the frequency hash map, we push the string and frequency to the min heap. If the heap size exceeds key, pop the lowest frequency string to ensure the heap only contains k most frequent words so far. Return the k most frequent strings by popping the remaining k strings from the heap. Since we are using a min heap, we need to reverse the result after popping the elements to ensure the most frequent string are listed first. Time complexity is O of n log k. Space complexity is O of n. O of n space is used to store a hash map, which is the same as approach 3. O of k space is used for heap, which is less than approach 3. In approach 3, at most O of n space will be used for the heap. So approach 4 is the best solution because it potentially takes less space complexity for the heap.